options as we go along. So let's go down to selecting our parts. Now, as I mentioned in the production drawing, your parts need to be exploded so that they're not touching. So each outer closed perimeter is a part, and then anything that's inside, there's an option here, preserve parts within part relationships in NEST, okay? If you're familiar with prior versions, you may be familiar with this being called for engraving and sign making. And basically what that means is your part has areas inside that you want to maintain with that part. In other words, this is not a part, this is a feature of the part, which is the outer perimeter, okay? So each of the parts are laid out. And also I want to make a note here, this is not a text entity in Rhino. You can use your text, the text entity tool in Rhino, but you need to explode it into geometry. So these letters are actual geometry. So they need to be geometry. Okay, so let's go ahead and we're going to select our parts. We're just going to window select everything. Okay, we'll press enter. So you'll see now that each of the parts turned red. That means it has been added to the parts list. And let's just go over here and turn those pop-ups off. Okay, so each of the parts were added to the parts list table. So if you look down here, you'll see that part 1, the green is the outer perimeter, and then it calculated it had some inner cutouts. So I'll just scroll through those real quick. So there's a number of cutouts inside that part. So it will automatically place the cutouts with the part, okay? Especially since we had this option checked. So it just went through all the parts. Now, you can nest if you only, if they were only going to machine or only going to assemble one assembly, maybe they only need to nest, one part for each sheet. So, okay, for one assembly. So we're going to just make it a little interesting. We're just going to say 2 parts. So we're going to nest enough components to assemble 2 complete jig fixtures. And we're just going to right click on this and say make all the same. So all the parts now as a count of 2. The priority, we're not going to really show that, but we can talk about it. The priority, if you want, starting in the lower left corner of the sheet, if you want certain parts to be nested first so that they take priority over other parts, you can give a priority value here and it'll rearrange them so that your parts are in the priority that you want them nested. And then orientation, we will be showing you this. Have checkbox for fixed. It just means that the part is going to stay in the orientation that it's staged in on the sheet. So it's not going to rotate it. It's not going to move it. Well, it'll move it, but it won't actually rotate it at all. Okay. And there's a good reason to do that. And I'm going to show you that in a second. Grain direction. This is another method of controlling how the parts are oriented. Obviously, on a 12 by 5 sheet, the grain is going to be going in the long X direction. Okay, but there may be sheets where the grain is going this way. It just depends on what parts you have and how you want them oriented on the sheet. So you can tell it what is the grain direction, okay, for the sheet in the X or the Y, and then when you do the components, you can set the grain direction for the component. So let's go ahead, and we've got all of the parts. Okay, if you don't see a part that's in red, that tells you that it has not been added. Okay, so we have all the parts, we have all of the cutouts for the parts, and you'll see we have 24 parts in the nest. So we have some additional options down here. Obviously, select your parts. You can remove all your parts, and or just remove one part. The orientation step angle. This is a constraint that tells the nesting algorithm, how many degrees can these parts be rotated in order to get fitted into the nest. So I have it set to 1 degree, which means that it's going to rotate it however it needs to rotate it to get it in there. Now you could set this to 90 degrees, say, if you only want your part to be at the fixed position or rotated 90 degrees, just those two orientations, and it'll constrain it to those two possible orientations. But we're going to use 1 degree. And then we have a mirror parts for nesting. If your parts, if it doesn't matter whether it's mirrored, upside down or right side up. And so in this case, it really wouldn't matter because these are all cutouts that are going to be all the way through the part. So in other words, all these profiles are going to be cut out on 3/4 inch sheets of plywood. So you could nest them, but we're not going to do it in this particular example. You just need to make sure that, if it's nested, it's not going to cause any trouble when you go to use that component in an assembly. So this one here, allow parts inside of other parts. If you are nesting just general profiles like our circle, a square, or some complex shape, whatever, and it has a cutout in the middle, if you think of a donut, okay? So the donut has a cutout in the middle. That sheet stock in the middle can be used to nest additional smaller components. So that's what this option here is for. And then we talked about that. So let's talk about, again, as Joe mentioned, if you've got any questions as we go along, put them in the questions panel. We'll get to them. So
Don, if you go back to that previous one, I want to talk about that why it's grayed out, the yellow parts.
Okay.
You might wonder why the yellow parts inside other parts is grayed out. That's because the next checkbox is checked. So what we're saying is we're preserving the parts within the part relationship in the nest, which means we're saying, okay, these are cutouts, and so they're not islands. So anything inside of a part is considered as a cutout rather than like a, it's an entire part that you want to keep and not put anything else inside.
Mm-hmm.
But if there's a hole in the part, then you uncheck that, and then you can use the allow part inside other parts. So thank you.
Okay, so we got our part selected. Here, let's talk about this thickness filter. If you drop this down, you see that we only have Z0. So our sheet that we created, needs to be a thickness of 0. So if you go back up and look at the sheets, it's a thickness of 0. Even though it's going to be a 3/4 inch plywood sheet, the actual nesting that we're doing right now, the parts have no Z thickness. So the thickness on the sheet has to match the thickness of the parts that you're nesting. For example, if you had a part.
So,
go ahead.
Yeah, I was going to explain that. Go ahead, Don. Sorry.
No, okay. So if you have a component that has a thickness and you have a component that has a different thickness, for example, you can nest 3D parts like solids, okay, or 2D parts. So we're nesting all 2D parts. But if you could actually nest 3D parts, okay, and if your parts have different Z heights, then you would need to have a sheet for each part that's a certain thickness. And that's why you have this drop down here that tells you what are the different thicknesses of these parts that you have added to the parts list. Okay, so we only have parts that are of 0